Section 9.9, Modeling with Quadratic Functions. So in this section, we're going to use a quadratic function to make predictions. So in the last section, we had the following data table. So we had years since 1990 and the annual bottled water consumption in billions of gallons. We were also given the following quadratic model to use, where consumption depended on how many years it was since 1990, and that was given to us by the function 0.021 t squared plus 0.04 t plus 2.25. When we looked at the graph of this quadratic model and the scatter diagram, the quadratic model looked like it fit really well. It passed through very closely to all of the points in our scatter diagram. But where did that model come from? So in the last unit, we learned how to use linear regression to find the equation of a line of best fit. So we got some y hat was equal to ax plus b, where we had a linear equation. And in this section, we're going to learn how to use quadratic regression on our calculator to find the equation of the parabola of best fit. And so now we're going to get a y hat that's going to equal ax squared plus bx plus c, where again, a cannot be 0, okay, b or c might be 0. Okay. All right. So as with most of these problems with data, the first thing you would do is push stat 1 to enter two lists of data, and then stat over arrow to calculate, and quadratic regression is choice number 5. Okay, so just like with linear regression, after you pick that, you need to tell it where you stored your x's. So this is wherever your explanatory variable is, wherever the response variable is, and this is going to be where we're going to store that equation. Okay, now some of you will have a screen when you push here, it will actually say xlist, ylist, and regression equation. So you're not going to enter these three things separated by commas, but next to xlist you would type L1, next to ylist you would type L2, and next to regression equation you would type a Y1. Okay, and those key punches are given here. And then when you hit enter, again it gives us our coefficients A, B, and C down below here. And then it gives us this value of r squared. And we're looking for a value of r squared in year 1. Okay, so r squared is always a number between 0 and 1. And the closer it gets to 1, the better the model fits the actual points in the scatter diagram. And again, we're going to put a little hat on top of the y, because y isn't going to be exactly equal to this. We're just looking at a model that best fits the data. So this is going to be an estimated or predicted value of that response variable dependent on whatever our explanatory variable is. All right, so let's take a look at the data from last time. So use the data above to answer the following. So we're asked to use the quadratic regression feature on the calculator to get the equation of the best fitting parabola for the given data. And we're asked to round the coefficients to 3 decimal places. Okay, so again, we would start by pushing stat 1, and that would open up our screen to type in our data. So let's push stat and 1. And let's see, well, it looks like I still have my data from that last example. So next to L1, we would type in 0, 5, 10, 15, and 20. And next to L2, we type in 2.2, 3.1, 4.7, 7.5, and 11.4. So again, you can push pause on the video while you take your time to enter all of your data in there. Okay, once the data is in there, we're going to push stat, and we're going to go over to the calculating menu, so right arrow over. And we want the best fitting parabola, so we want quadratic regression, so we're going to push button 5. And then again, I have an older model calculator here. Some of you will have a place to put in these 3. Okay, on mine, I need to put in my 3 inputs separated by commas. So I need to tell it that my x variable's in L1, my y variable information's in L2, and I want to tell it to store the equation in y1. So we're going to push variables over to y variables, function, and then I'm going to choose y1. So this tells the calculator to find the best fitting parabola, taking the ordered pairs from L1 and L2, x's from L1 corresponding y in L2, and then to store that equation in y1. And again, we need to keep in mind that we are going to put a hat on that value of y. So here's our output screen. And so if we write our equation, as it appears on there, it would look like this. So the y hat for a given x would be a, and they told us to round to 3 decimal places. So we would get about 0 to 1 x squared plus 0.045x plus 2.249. Or, in using the variables from the context, we would estimate that this consumption at a given value of t was 0.021 t squared plus 0.045 t plus 2.249. So now we're asked to use the equation that we just got. Oops, we kind of skipped a part here. So let's do this. That was our equation. Now we're asked to use this equation to predict the bottled water consumption for 2014. So we want to predict the bottled water consumption. So we want to predict, so there's our hat, bottled water consumption. And we're given the year 2014. Okay, so this is a t-value. Let's see, we were years since 1990, so this would give us a t-value of 24 years since 1990. 1990 plus 24 will give us 2014. Okay. So we want to take this equation we got, I'm going to smush it down here since I misplaced that information, and put in here a 24 for t. So we're going to get 0.021 times 24 squared plus 0.045 times 24 plus 2.249. Okay, so this is one way that we can get this answer. The other way is we need to remember that we actually stored this equation next to y1. So another way that we could get this same information, so the estimated consumption when t is 24, is to use that stored equation and plug in 24. So to type y1, we would do variables over 1, and then parentheses, 24 parentheses, and we would get about 15.17, and that's billion gallons. We put the units back on there. Okay, so we would estimate that the bottled water consumption for the year 2014 would be about 15.17 billion gallons. All right, so now part C, we're again asked to use the equation in part A and the intersection feature on our calculator to predict when, so now T is in question, to predict when the bottled water consumption will reach 20 billion. So now we're given that consumption at sometime T is going to be 20 billion gallons. So we need to solve the following. So now in part B we were given an input and asked for the output. Okay, now we're being given the output and we're being asked for the input. So we want to find or solve the following for t. So we want to take our equation 0.021 t squared plus 0.045 t plus 2.249. And we want to know for what value of t that we put in here will it give us an output of 20. Okay. Well, we've learned in these last sections several ways to solve this quadratic equation. And our first step would be to subtract 20 from both sides so that we would have a 0. And then with all of our decimals in here, I would probably then use the quadratic formula. But on here it did say that we're allowed to use the intersection feature on the calculator, so that's what we're going to do on this one. Okay, so this expression, remember, we had it stored next to y1. Okay, so next to y1, I'm just going to put it's already there. But what we would want there is this 021 x squared whole 45x plus 2.249. But we already had it stored there. So when you push y equals, you should notice next to y1 that this equation, with a lot more decimal places on each of those coefficients, is already there because we stored it there. But then next to y2, and we're going to put the other side of the equation, which is 20. So if we push window, so let's go in here. So if we push y equals, we'll see that that equation was stored. And next to y2, I'm going to clear out what was there, and we're going to put in there 20. And then we're going to go into the window, and we're going to start it in year 0. And before we tried 40 for whatever other previous one, so we'll just start there, and if it's not wide enough, we'll make it bigger. So we'll try zoom 0. So remember, to be able to use the intersect feature, we need to be able to see the intersection on screen, which we can. Okay, so now we're going to use second calc, and we're going to use the intersection feature 5. First curve, second curve, and then guess. There's only one intersection on screen, so we don't need to give it a guess. In some of the problems in the last section, we had 2 intersection points, so we moved the cursor to one and then the other. But here, there's only one, so we're just going to hit enter. And we can see that that happens around 28.3, comma 20. If we round that off to about the nearest years, the homework probably will about 28. Okay, so that intersection point is about 28, 20. Okay, and where this was years since 1990, and this was actually in billions of gallons. So we were asked to use the equation to predict when that would happen. So 28 years after 1990 would be the year 2018.